Alright kiddos, today we're going to talk about average and instantaneous velocity, which are basically the same thing as average and instantaneous rate of change, but with real-world applications. So, our objective is to be able to apply the slope of the secant and slope of the tangent lines to determine the average and instantaneous velocity of real-world functions. Connection. A function has a positive average rate of change on the interval from 2 to 5. Is the function increasing, decreasing, or constant on the interval from 2 to 5? So what does this really mean? Average rate of change. So that means when x is 2 and x is 5, that means the slope of the tangent line or the slope of the secant line is positive. But the question is that a sign of what's happening to the function? So if you think about what could be happening, you could have a parabola. Okay, so the parabola on part of this function would be decreasing, and then we hit the minimum and we would be increasing. Okay, so at that point, you really cannot determine by the slope of the secant line what's actually happening to the rest of the function, because the slope of the secant line is really what's happening at point 1 or from point 1 to point 2, and not what is happening in between those. So, average rate of change. What is the difference between average and instantaneous rate of change? So the average rate of change, if you think about the average rate of change, it's what's happening from one point to another. So if I just use a parabola, for example, from here to here, I know that from point A to point B, the graph or the slope of the secant line is increasing. Where if I take the tangent line, if I look at the tangent line at this one point, because right here, this line has a negative slope, I know the function's decreasing. If I take the slope of the tangent line right here, because the slope is positive, I know that the tangent line is increasing. If I look at what's right here, the slope of the tangent line is decreasing. So the slope of the tangent line is a better indicator of what's going on at a single point or at one instant on the graph. Okay, average velocity is basically going to be the slope of the secant line. And basically it's going to be the velocity between 2 points. So it's going to tell you what the average velocity was between those 2 points, but not really what's happening in between. So you could have sped up, slowed down, whatever, but it's only going to tell you what's happening from point 1 to point 2, where the instantaneous velocity is the slope of the tangent line. And basically, the instantaneous velocity is going to be the velocity at that one moment in time. All right, so let us do a couple examples. So we have the volume of a right circular cylinder, height 3 feet, and radius is going to be V of R equals 3 pi R squared. Find the instantaneous rate of change of the volume with respect to the radius at R equals 3. Explain the difference between V of 3 and V prime of 3. So, if we have V of R equals 3 and I want to find V prime of R, that's going to be the limit as h approaches 0, and normally it would be f of x plus h, but this is going to be v of r plus h minus v of r all over h. So keep bringing everything down. Some of you are better off to hit pause and just do the work on your own. So this means I'm going to substitute in r plus h, subtract the original function. I don't know what I was doing there. Subtract the original function, which is going to be 3 pi r squared, all over h. Continue on with the difference quotient. So this is going to be 3 pi times r squared plus 2rh plus h squared. Then everything else comes down and stays the same. Limit as h approaches 0, distributive property, 3 pi r squared minus 6 pi rh plus 3 pi h squared minus 3 pi r squared all over h. Got a little canceling to do, so these cancel. I won't skip any steps because some of you need all of them. So the limit as h approaches 0. At this point in the problem, you have a GCF, so I can substitute, or I can GCF out the h. And this is going to be the limit as h approaches 0. These h's cancel. Negative 6 pi r plus 3 pi h. And now h is going to be 0, so essentially this goes to 0, which means this whole term goes to 0. So what we end up with is that b prime of r is going to be negative 6 pi r. I don't think it should be negative. Nope, it's not negative. Time out. Ms. Schwartz made a sign mistake right here. This should be positive. I don't know why. I don't know where I picked up a negative. Can't be negative. Okay, so v prime of r is going to be 6 pi r. So if I find v prime of 3, that is going to be 6 times pi times 3, which is going to be 18 pi. And if I think about v of 3, okay, if I find v of 3, go back to the original problem. Okay, so v of 3, this means the volume when the radius equals 3 is 3 times 3 is 9 times 3, 27 pi units cubed. Okay, so v of 3 is straight up the volume. V prime of 3 means as the radius is increasing at this one moment in time, that means the volume is increasing. I think this is the way I need to see the original problem, and I can't. Hold on a second. I need to get my notes out because I cannot go backwards a slide. Sorry about this. Okay. So the volume, if you look at the original problem, the volume V of a right circular cylinder of height 3, find the instantaneous rate of change of the volume with respect to the radius at 3. Okay, so yeah, V prime of 3 is the rate at which the volume is changing when the radius is 3. So when we say 18 pi, this is basically the instantaneous rate of change. So it's the instantaneous velocity. So it's how fast we are changing when the radius equals 3. All right. I'll have a better explanation for that when I see you tomorrow. Okay. Problem. In physics, it says it is shown that the height s of a ball thrown straight up with an initial velocity of 80 feet per second from a rooftop 96 feet high is negative 16t squared plus 80t plus 96, where t is the elapsed time that the ball is in the air. The ball misses a rooftop on its way down and eventually strikes the ground. Okay, so sketch a diagram of the situation. So really what's happening here is you're here on a rooftop, you toss an object up, and then it comes down to the ground. So this is time, and basically this is height as a function of time. So if we want to know when the ball strikes the ground, this happens when your height is 0. So for part B, when h of t is 0, that's when the ball strikes the ground. So negative 16t squared plus 80t plus 96 is going to equal 0. And if you take a minute and we solve for that, I can GCF out the negative 16. And so you can divide out the negative 16, which leaves you with t squared plus 5t plus 6 equals 0. And if I GCF out a negative 16, time out, this is going to change these two signs to negatives. Rough video day today. So now this is going to be t minus 6 times t plus 1 equals 0. So when time equals 6 or time equals negative 1, my height is 0. And that actually kind of makes sense, because if you look at your graph, this is going to be negative 1 and this is going to be 6. So 6 seconds into the ball, into the flight. So 6 seconds into the flight, the ball hits the ground. Okay, and at what time t will the ball pass the rooftop on its way down? So if you come up to your graph, you're looking for this t value right here. And basically it tells you that the roof is 96 feet tall. So you have a 96 right here. So I'm going to set this problem up for you, and then you guys can hit pause and work it. I don't know how much room I have here. So basically, when the height is 96, you have negative 16t squared plus 80t, I don't have enough room, plus 96. In the end, you move that 96 over here, so you get 0 equals negative 16t squared plus 80t. Again, I'm going to GCF out the negative 16. This time I'm going to remember that when you GCF out a negative, that sign is going to change. Oh, I should have said GCF out a t too. So you get 0 equals t times t minus 5. So when time equals 0, the height is 96, and when time equals 5, the height is also 96. So this is 5 seconds in, and if you look at your graph, it should make sense that initially the ball was also 96 feet in the air. So time equals 0 and 5. So basically 5 seconds into the flight, the ball will pass the 96 feet mark again. All right. So what is the average velocity from t equals 0 to t equals 2? So average means 0, so I need to come find s of 0, which is going to be 0 plus 96. So s of 0 is 96, which means the point 0, 96 is a point on your graph. And then I also need to find s of 2, not t. So if I do negative 16 times 2 squared plus 80 times 2 plus 96, that problem is calculator worthy in my world, so give me a second. Negative 16 times 4 plus 160 plus 96. I get 192, so s of 2 is 192, which means you have the point 2, 192 on your graph. So the average velocity is going to be the slope, which is going to be the change in y over the change in x, so the change in s of t over the change in t. So I'm going to take 192 minus 96, and then I'm going to take 2 minus 0, 192, 92, 96, so 96 over 0, cut 96 over 2, which is 48. And I think the units we're using in here is feet per second. Feet per second. So in this graph, your height was in feet, and then your time was in seconds. All right, so that's from one point to another. Then it says, what is the instantaneous velocity of the ball at time t? So now you are going to find the limit. Let's see, nope, let's restart that. You're going to find s prime of t, which is going to be the limit as h approaches 0 of s of t plus h minus s of t all over h. So s prime of t is going to be the limit as h approaches 0. I'm going to substitute in t plus h, got my plus, squared plus 80 times t plus h plus 96. And then I'm going to subtract my original function. And that's all going to be over h. So I need you to hit pause. I need you to work this out. And when you are done, you can resume. All right. I am taking a super shortcut here. And if you did all that work, s prime of t is going to be negative 32t plus 80. So if you know the calculus shortcut, you know how I got that so fast. Otherwise, you had to do all that work to get that answer. So now, negative 32t plus 80. So s prime of t is negative 32t plus 80. It says, what is the instantaneous velocity when time is 2? So s prime of 2 is going to be negative 32, substitute into 2, plus 80, which is going to be 16. So the instantaneous velocity is going to be 16 feet per second. So at that one moment in time, 2 seconds into the flight, the ball is traveling at 16 feet per second. Then it says, when is the instantaneous velocity equal to 0? So basically that says, when does s of t equal 0? Well, s prime of t equals 0 when negative 32t plus 80 equals 0. So that's going to be 32t equals 80 divided by 32. And if I simplify that, 4 goes into 80 20 times, 4 goes into 32 times 8, 4 goes into 25 times, so that's going to be 2.5. So 2.5 seconds into the flight, that's when the instantaneous velocity is going to be 0. Now, if you think back, and y'all can look back at your original graph, you had 96 here. Woo, ball flew up. It hit the ground here at 6. We know that the two heights matched here at 5. So basically, 2.5 seconds in, what this is saying is when the instantaneous velocity is 0. Okay, what's happening to my graph? Well, right here, the instantaneous velocity is the slope of the tangent line. So that's happening 2.5 seconds into the flight. And that is when the ball goes from increasing its flight path to decreasing. So every time the slope of the tangent line or the instantaneous velocity is 0, the ball is basically changing directions or going from increasing to decreasing. All right, moving on to example 3. So the following data represents the total revenue received from selling X bicycles at Tooney's Bicycle Shop. Part A says find the average rate of change from revenue from 25 to 150 bikes. So you're going to come to your chart, you're going to look at 25, you're going to look at 150, and we're going to find the slope. So the change in revenue over the change in the number of bikes sold. So 59,160 over 28,000. Oh, I lost my train of thought. Daydreaming. Okay, minus 28,000. And X is going to go from 150 to 25. Again, calculator problem. So 59,160 minus 28,000. And I'm going to divide that by 125. And I get 248.48. So that's going to be dollars per byte. And basically, I got dollars per byte because if you look here, your Y value is in dollars, and here, this is the number of bicycles. So when you went from selling 25 to 150 bikes at those 2 moments in time, from point A to point B, you were averaging a revenue of $248.48 per bike. All right. It says, in the context of the problem, explain the meaning of a negative rate of change. So basically, that's going to be dollars per bike. So if you're negative rate of change, basically it means you're losing revenue. And then it says the instantaneous velocity when 25 bicycles are sold is $521.69 per bike. Explain this in the context problem, and how is it different than the average rate of change? Okay, so basically, if the instantaneous velocity at 25 is $521.69, that means when you sold 25 bikes, you made $521.69 per bike on the 25th bike. It doesn't tell you what happened on the 24th bike. It doesn't tell you what happened on the 23rd bike. It doesn't tell you what happened on the 22nd bike. It is what's happening when exactly that many bikes are sold. Versus the average rate of change is what happens from a range. So from point 1 to point 2. But again, it's only what happens from that exact range. If you went up a bike or down a bike, that average rate of change is different. Alright, hopefully this is enough for you guys to get homework done tomorrow in class. If you have any questions, as always, we will get them answered tomorrow or Monday or whenever I see you next. Have a great night. Bye.